Okay, hello and welcome to the next video. In this one we're going to talk about, quite quickly, just what we mean by pressure, okay? And the basic formula we use to calculate it. Okay, so pressure is basically, as you know, sort of the force put on something over an area, okay? So we already know that if we push something with the same force, the smaller the area we're pushing with, the greater pressure we'll feel. The bigger the area, the less pressure. And that's fairly intuitive. We can think of that examples ourselves. If you push against your hand with your other hand, you don't really feel that much. If you push using the same force but with a pin, you'd feel a lot more, okay? And that's because the biggest thing that's really affecting the pressure is the area involved, okay? And that gives us our formula for it, okay? So this is a formula we should be very familiar with by now, okay? But it's pressure equals force over area, okay? If you wanted to put this in a triangle, you'd have pressure here, force at the top, and area there. And this would be what it looks like in your triangle, okay? The other things to remember are the units, okay? We already know forces in newtons, area. In physics we always do meters squared for the area, but pressure is in pascals, okay? The symbol for pascals is PA, so don't forget that. As a little bonus though, you've seen before when you've looked at past papers, sometimes they like to ask you what other units you could use for things, okay? So if we didn't use pascals, another unit we could use comes from the equation, okay? So pressure is force, which we measure in newtons, divided by area, which we measure in meters squared. So another way of saying this is saying, okay, well, it's newtons per meter squared, okay? So it's newtons per meter squared, okay? Or nm to the minus 2, okay? That's another way of writing pascals, okay? Don't do it like that, though, in a question. When you're working out a pressure, put PA, pascals, as your units. But sometimes in multiple choice, they might say pressure is measured in pascals, what else could it be measured in? And the answer would be newtons per meter squared, because it's force divided by an area. Okay, now, we know all about the equation, we know what they mean, so let's just look at a couple of examples of actually using it, so then we can just get a little bit of practice of that before we try them ourselves. So, this is the first example we're going to look at. A mass of 60 kilograms is balanced on a point of area 0.1 meters squared. What pressure does it exert? So let's write down what we have, what we're trying to find out. So we have the mass, well, that's 60 kilograms. We have the area, and it's already in meters squared, so we don't need to change it. 0.1 meters squared. And we're trying to work out the pressure. Something we're missing though, okay? And if we look at our formula, we don't know the force, okay? We also need to work that out. Now, it's not written in this question, okay? And if the situation is fairly obvious, it assumes you know it, okay? If not, it will say otherwise. But let's assume this is taking place on Earth, okay? How are we going to work out this force? Okay. Well, if this mass of 60 kilograms is balanced on its point, okay, where's that force coming from? Well, that force is coming from gravity, isn't it? Okay. And the force due to gravity, well, we know the formula for that. We calculate the force due to gravity using the equation mg. So let's do that then. We know our mass is 60. And we know G is 9.8. So let's pop that into a calculator and work out what that is. So that's going to give us 60 times 9.8 equals 588 newtons. And now we have everything we need to pop into our equation. So let's do that then. So our equation, P equals F over A. We've got a mark there for that. We've probably already got a mark actually as well for working out the force. So let's put that force in, 588. And let's divide that by 0.1. And if we pop that into our calculator, 588 divided by 0.1, that gives us an answer of 5,880 pascals. And we don't need to do any rounding here, that's already to 3 significant figures. And there's our answer sorted. So this would probably be a 4-mark question, okay? A mark for working out your force, a mark for your equation, mark for subbing in, and a mark for your answer with units, okay? Now, there was a little extra step there, working out the force, but we didn't need to rearrange the equation, and our area was already in meters squared, okay? One of the common things which people trip up on in pressure questions is when the area isn't in meters squared, or if they need to rearrange it, okay? So we're going to look at a question now that will require us to rearrange it and will require us to put our area into meters squared, okay? Question this time then is, how much force do I need to push a block with to exert a pressure of 6,000 pascals? Okay, and the area of a block that's being pushed against it is 200 centimeters squared. Okay, so again, we'll write down what we have, what we're after. I know the pressure this time. Let's pop that straight down, is 6,000 pascals. And I know the area is 200 centimeters squared, and I'm trying to work out the force. Okay, so first things, that's not the standard units for area, okay? So remember, standard units for area are meters squared, okay? And we've been over this in class. The way to get from centimeters squared to meters squared is to divide by 10,000, okay? And so let's do that. If we do 200 divided by 10,000, that's going to give us an area of 0.02 meters squared. Okay, now we have the two things we need. So our normal equation is P equals F over A, but I want to rearrange this to get the force. So if we look up at our triangle, okay, cover up force, well that tells me it's pressure times area I need. So let's do that then. Force equals pressure times area. Pressure 6,000 times the area 0.02. Again, just pop that in a calculator. 6,000 times 0.02 gives us a force of 120 newtons. Be careful to remember your units. Okay, now those two examples there, they're probably all you need to do any sort of standard pressure question, okay? You've practiced using the equation in its normal form, you've practiced rearranging it, you've now also practiced getting a force when you only know the mass, and you've practiced changing the area into the standard units. So if we put all these together, we'll be able to do some questions now on pressure. Now, as you know, the pressure stuff does go on to involve gas laws and things. It gets a little more complicated, but for the time being, we're just going to practice using this equation and make sure we're comfortable with that. Okay, so, right, hopefully that was all understandable. If not, get in touch, and thank you for listening.